So, the Einstein equations can theoretically predict black holes. They can also theoretically predict white holes. And we've observed around black holes. What if white holes are actually a thing? Like, if they're constantly spewing out different stuff and things, like, wouldn't that explain a lot of the dark flow? Maybe dark energy? I'm just saying, we conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-Rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? The memes here. Oh, look at that beautiful artist renditioning right here. Should totally support your independent artists here. Links in the doobly-doo. But what the heck is a white hole? Now, I was just thinking about this a little bit earlier, and I'm like, okay, well, if black holes are like sucking everything in, and white holes essentially like blow everything out, I'm like, we've seen black holes. If we can get white holes, and they're doing their thing, wouldn't that just look like a bunch of, I don't know, energy? Something that's gonna, I don't know, maybe spewing out a bunch of hot, dense neutrons and stuff that might decay into some protons, some electrons, and some anti-neutrinos. Shout out to Gally Fisher. Neutron decay cosmology is very interesting. But with most of the standard models and everything we have of cosmology, I'm like, all right, isn't this like the easiest answer? Well, we haven't seen it. To be fair, I don't think we've really seen black holes. We've seen the stuff around them, the effects of black holes. Wouldn't a white hole just be like a whole bunch of like gas and energy going on in different ways? It's literally an obscuring mist, except instead of in Dungeons and Dragons and or Pathfinder, it's the Bower cosmos. In general relativity, a white hole is a theoretical region of space-time and singularity. Some folks would disagree with that. That cannot be entered from the outside, although energy, matter, light, and information can escape from it. In this sense, is the reverse of a black hole, which can be entered only from the outside, from which energy, matter, light, and information cannot escape. White holes appear in the theory of eternal black holes. Oh, links to a wormhole. There's one about eternal black holes. How very interesting. In addition to the black hole region in the future, such a solution of the Einstein field equations has a white hole region in its past. These are the parts that started to seem very interesting to me for other reasons. We stick to the standard stuff and things that are widely talked about in cosmology for now. We can conjecture more later. This region does not exist for black holes that have formed through gravitational collapse. However, nor are there any observed physical processes through which a white hole could be formed. So we don't have any idea how it could happen. I just find it interesting they say this doesn't apply to black holes that form through gravitational collapse. Again, some people may take issue with that. Supermassive black holes are theoretically predicted to be at the center of every galaxy, and that possibly a galaxy cannot form without one. Stephen Hawking and others have proposed that these supermassive black holes spawn a supermassive white hole. May Professor Hawking rest in peace. Apparently, he lost a lot of bets. Now, like black holes, white holes have properties like mass, charge, and angular momentum. They attract matter like any other mass, but objects falling towards a white hole would never actually reach the white hole's event horizon. Though in the case of the maximally extended Schwarzschild solution, I'm going to go to this for just 1 minute. Oh, totally never seen that before. It's totally not the same thing, and this is the imaginary part. Oh, there seems to be 3 things in the real part. In general relativity, Kuskov Schweizers, I apologize, completely butchered your name's coordinates, named after Martin Kruskel and George Sekros, are a coordinate system for the Schwarzschild geometry of a black hole. These coordinates have the advantage that they cover the entire space-time manifold of the maximally extended Schwarzschild solution and are well behaved everywhere outside the physical singularity. Again, people take issue with that. There's no misleading coordinate system at the horizon. Cool. And it's got this cool little thing. Oh, look, you send the things in there. Whoop, whoop, whoop. We go back to white hole. Brought to us by Wikipedia again. Take it for what it's worth. Where were we here? We already did that, didn't we? Okay. We'll just read over here. The possibility of the existence of white holes was put forward by a Russian cosmologist, Igor Novikov, in 1964. White holes are predicted as part of a solution to the Einstein field equations, known as the maximally extended version of the Schwarzschild metric, describing an external black hole with no charge, no rotation. Here, maximally extended refers to the idea that space-time should not have any edges. For any possible trajectory of a free-falling particle following a geodesic in the space, I think it shows a pretty cool thing. All right. In the space-time, it should be possible to continue this path arbitrarily far into the particle's future unless the trajectory hits a gravitational singularity like the one at the center of the black hole's interior. Again, people disagree. In order to satisfy this requirement, it turns out that in addition to the black hole's interior region, that particles enter when they fall through the event horizon. From the outside, there must be a separate white hole interior region, which allows us to extrapolate the trajectories of particles from an outside observer sees rising up away from the event horizon. An observer outside using Schwarzschild coordinates in falling particle takes an infinite time to reach the black hole horizon infinitely far in the future. While outgoing particles that pass the observer have been traveling out outward in an infinite time since crossing the white hole's horizon infinitely far in the past. Oh. Again, I find this interesting. However, the particles or other objects experience only a finite proper time between crossing the horizon and passing the outside observer. Proper time along a time-like world line is defined as the time measured by a clock following that line. It is thus independent of coordinates and is a Lorentz scalar. A proper time interval between two events on a world line is a change in proper time. Apparently, there's some videos that people talk about different stuff and things there. Between crossing the horizon and passing the outside observer, black holes, white holes appear external from the perspective of an outside observer in the sense that particles traveling outward from the white hole interior region can pass the observer at any time. The particles traveling inward, which will eventually reach the black hole interior region, can also pass the observer at any time. That's all I really had. I'm just... Listen, we have this article here. Yes. Compelling mysteries. Okay, we're going to rampantly conjecture here for a second. Okay. So again, just base what we know in cosmology and stuff. It's like, okay, we got dark energy, we got dark matter, we have these observed effects that we need answers for. At least as far as dark energy goes, if white holes did exist, and at least according to the Einstein field equations, they can exist in some of these answers. If they're out there, I mean, would we really even notice unless we literally like stumble upon them? What are we going to see? A whole bunch of hot gas and everything. I don't know what's in the middle of those nebulas. I'm just saying, we're going to need a lot of new technology. It's a good thing we got a whole bunch of cool experimentalists that can figure these things out. Rampant conjecture time here. We're going to use the HF8 model that basically Thad's been working on. I'm sitting there, I'm like, so in the past, observationally, we would have a white hole, or at least something that would appear like that. And in the future, you basically have a black hole. I don't know. Does that sound like eternal cyclic cosmology? It kind of sounds like it to me. It's like, all right, you're emerging. Why? Well, if you take the complement of the hyperbolic figure 8 knot, if you take that, if you have the ability to actually ride into the vortex, I'm just saying if you come out of there and there was mass going in, it's good chance it's going to be really hot and energetic. Some may say it might be kind of a quark gluon plasma as it cools. And eventually, the stuff circles around in an hypersphere of maximal volume. Things are going to attract. Maybe I'll have different vortices, because if it was kind of superfluid, like I'm just saying, any type of rotation, that vortexes kind of just happen. Professor Feynman apparently had a dream about that. And then there was observational evidence. But if that happens, if something's coming out, it's got to be stuff going in. It cycles. Let that be the observed non-gravitational collapse. I might actually argue with that myself, but we won't here. It's even more extreme rapid conjecture than for what we're actually speculating here. Again, just the opinion of a dude on the internet. I think this might explain a lot. I need to learn how to use more of these programs. I need to learn to code. I said I was going to do it last year. Somebody hold me to that. But thank you, everybody that's joined. It's good to see you, Mark, LDG. We're going to free on that. And Lewis, good to see y'all. All I know is there's a lot of darkness out there. But I did see a wise woman that apparently said it's always darkest before the dawn. But with that, be sad, everybody. Be safe. And
we won't be going hungry if we do this. That's for sure.
Dude, my hat has made over $10 tonight.
I guess I'm going to have to wear a cowboy hat on here with you next time, too.
Howdy.
Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.